This is a laser cutter in the Design and Innovation Lab in UW-Madison. It cuts material with a laser into intricate shapes that engineers can use to assemble prototypes. Despite its beneficial qualities, it releases VOCs, which can cause health complications if inhaled. This is Matthew Mabey, the shop manager at the Design and Innovation Lab, and he has tasked us with designing a prototype that filters out VOCs.
We're Team Fresh, and this is our final prototype, the Onion, keeping the Wendt air clean. This design started out as a concept of an air purifier that branched into 3 separate designs. A revision of the prototype that was given to us that included 3 carbon HEPA filters and a box fan, an electrostatic cylinder that utilized a charged particle system and collection plates, and a multi-layer prototype consisting of 4 fans and 2 kinds of air filters. These 2 kinds of air filters were the carbon HEPA filters and then also a UV filtration system. Before picking a prototype to continue with, we decided it would be best course of action to block up all the holes and seal everything off in the original prototype to make sure that we couldn't use that prototype to continue with, because that would mean low cost. We already had a plan to go off of. But that unfortunately was not the case, as we found out through our testing, and therefore we decided to go with the Onion because it would be most effective at filtering out VOCs. After we chose to pursue the Onion prototype due to its high efficiency, from there we built a cardboard prototype consisting of 1 fan and 1 filter. With that, we tested airflow and how it would work with our design and where exactly the particulates and dust would go. Next, we laser cut an updated model out of wood so that everything would be more stable and the dimensions would be more exact. Afterwards, we tested the airflows of different areas of the design and discussed dimensions of the final prototype so that less airflow would be lost halfway through the design due to gaps between the filter and the box. We also updated the design so that the filters would be easier to remove to promote ease of use of the final product.
Once we received the old prototype, we tested the filtration system to find that the sensor did not work how we wanted it to perform in our final project. So we created a schematic of the wiring and took everything apart to start the new coding. We coded the Arduino to turn on the fan once the sensor detects a certain threshold of dust in the air and turn off after the dust concentration drops. We also wanted to bulk some of the electronics and wiring, so we removed the level converter once we found it did not play any role in the powering of the sensor or fan. We soldered a USB-C adapter to the relay module in the fans, which serves as a power source, and we also soldered some loose wires to ensure the connection between the sensor and the fans. Lastly, we integrated the fans and electronics into the casing to test the filtration.
After the electronics were put together and finalized, we proceeded with the testing process of it. During this process, we tested the sensor, as when the VOCs or dust hit the sensor, it would then communicate with the relay machine where it communicates with the fan. Additionally, within the Arduino code, we have set the threshold to roughly 3 micrograms per meter cubed. We chose to set the sensor to have a sensitive threshold, as it will allow the fans to react properly, even when there is a little bit of dust in the air. After the threshold gets hit, the fan is then set with a 3-second buffer time before it actually turns on, and it will be powered on until the VOCs within the air surrounding the fan becomes less than 3 micrograms per meter cubed, as then the surrounding air will be clean.
Final prototype utilizes the relationship between airflow and air pressure to effectively filter out VOCs and other particulate. The final prototype has multiple layers of fans and filters. The multiple layers of fans and the tight seal on the outside of the shell helps increase the air pressure. Since air pressure is inversely correlated to airflow, the air pressure is increased inside of the shell and air flows from the high pressure area inside the box to the low pressure area outside the box. This pushes the VOCs and particulate matter through the filters and ensures effective filtration. The fans operate at similar wattages to ensure similar speeds and similar airflows, and the airflow out of the filter is between 0.5 and 1.5 knots, which is the approximate airflow needed for an effective VOC filter. The VOC filter doesn't want the airflow to be too fast because then it won't have enough time to filter out the VOCs, but it also doesn't want it to be too slow because then no air will be pushed through the filters.